Okay, let's look at how to graph the derivative function given the original function. So here we've got in red a function of x, and what I want to do is have a look at how, just talk you through the process by which we will graph the derivative. Okay, so the derivative function, the gradient function, whatever you want to call it. Let's pull another color out and see what to do about this. Okay, so on the same set of axes, I'm going to look at graphing the derivative of this curve here. Okay, starting point is always to go to your stationary points, because the derivative, the gradient at our stationary points is 0. So I know that the curve I'm going to graph, the derivative graph, is going to go through the x-axis there because the value of the derivative there is 0. The value of the derivative of the function at this point is also 0. So we'll track that back up to the x-axis, and we'll make sure our derivative curve goes through there. So you might have thought, okay, this looks like a cubic. When you derive a cubic, you get a quadratic, so we're expecting a parabola out of this. It's also a positive cubic because it's heading off in this direction here. Any graph that heads off in that direction, the positive direction, is a positive cubic, so we're expecting a positive quadratic in return. Okay, so all I need to do now is say, okay, well, left of this, let's just check it out. We've got this is all positive and reducing, so it's a positive. We need to represent a positive section there. Now after this it turns negative, so it's all negative to there. At some point here, interestingly, we'll have a dip in this, won't we? And we'll probably just have a little think about what that represents, what the significance of that is. But there's my f-x, f-x. Okay, and the key points are pulled up there in terms of where it hits the x-axis. One other thing that's worth looking at here is where f-x equals 0, and if we then looked at graphing the second derivative, we would want to represent this point. Let's say it's just there. Let's pull out another color. And that would be, my second derivative would go through the x-axis there, because what does that represent? The f-x equals 0, or the rate of change of the first derivative equals 0. That's where the second derivative equals 0, and that's where our point of inflection lies. So that there meets the red curve at our point of inflection. That's worth a little mention. That lines up to the turning point of the derivative graph. So that's my point of inflection. Right, that's where, remember, it changes from concave down to concave up. So what's my second derivative curve going to look like? Okay, well, the rate of change here is decreasing, isn't it? Decreasing, decreasing, and then increasing. So that means I've got a negative gradient here. So I'm negative this side, and I'm positive on this side. So that means I'm going through the x-axis there. So I don't really know what the slope's going to be. I'm not too worried about it, actually. I just need to get this line going through there, and this line here is this linear function here is going to be my y equals f double dash x. Okay, that's making sense. If we started with a cubic, our quadratic is our first derivative, and a constant is going to be a linear function is going to be our second derivative. Our third derivative would be a constant. That goes through there, which goes through the turning point of f-x, and remember f-x went through the turning points of fx. So that's how to graph the derivative. Always go to your turning points at first up, plot them as going through your x-axis, representing equals 0 at those points. That gives you a little framework to work in, and then work in the intervals around that. Okay, so that means we will be able to tackle exercise 7U, which was one of the exercises we left out of our list. So we can certainly have a go at that. Now I expect on Monday we'll be doing that, plus polishing up on any other questions from previous or other exercises that we haven't done yet. Okay, I'll see you then.